everyone, in previous class we have studied all about the periodic trends in a physical properties of an elements like electronegativity, electron affinity, atomic size and ionic radius like this. In this class I am going to discuss with you the periodic trends in the chemical properties of the elements. Periodic trends in chemical properties of elements like valence or valency of the elements, and second one, anomalous behavior of elements. First, we have to go with valency. So, what is the trend of the valency of the elements in periodic table? First, we have to know periodic trend of the valency. You must know about the meaning of valence electrons and the valency. So, what is the meaning of valence electron? Already you know that. Just try to remember. Yes, that is the right answer. So, valence electron means the electrons present in outermost shell or the electrons present in valence shell. Just consider, in a sodium atom we are having 11 electrons, and at the last means in a valence cell or in a outermost cell we are having a 1 electron. So this electron is valence electron. So once I wish to repeat, what is the meaning of valence electron? The electrons present in a valence shell or the electrons present in a outermost shell. So that electron is called as a valence electron. See the example. Already now we are having 18 groups in our periodic table. Here I am talking about representative elements. So what do you mean by representative element? In a previous class I already told you the representative elements means the S block elements and the P block elements together called as a representative elements. Just see here. So in a group 1, all elements have 1 electron in their outermost shell, 1 electron in their valence shell. So the valence electron to the group 1 elements are 1. And in a second group we are having 2 electrons present in their outermost shell. So the valence electron of group 2 elements are 2. Like this, group 13 we are having 3 electrons in our outermost shell. In a group 14 we are having 4 electrons. Group 15 we are having 5 electrons in their outermost shell. In a group 16 we are having 6 electrons in their outermost shell. Here we are having 7 electrons in a group 17. In a group 18 we are having 8 electrons in their outermost shell. So the valence electron of group 18 is 8, 17 7, 16 6, 15 5, group 14 4, group 13 3, group 2 2, group 1 1. So now I hope you know about the valence electrons. And next, what about the valency? Already you know the definition of valency, and you learn in your 9th and 10th class the definition of valency or the meaning of valency. Just recall it, guys. Yes, the valency means the combining capacity of electrons. So called as a valency. In this class, I am going to discuss with you a new definition of a valency, and I am going to tell the detailed explanation about the meaning of valency. So what is the meaning of valency or valence? See here, the number of electrons lost or gained or shared during the chemical reaction. For example, if the formation of NaCl takes place, how many electrons are transferred? Sodium loss of 1 electron and chlorine gain 1 electron. So by losing and by gaining an electron, the NaCl compound is formed. So like this, when the chemical reaction takes place, then what happened? The some elements are gained the electrons and some elements are lost the electrons, and some elements are shared the electrons. For example, and consider a HCl. Here what happened? Hydrogen also share a 1 electron with a chlorine, and chlorine also share a 1 electron with a hydrogen. So like this, in this reaction, when the formation of an hydrochloric acid, in this reaction what happened guys? The sharing of electrons takes place. Here what happened? The losing of electrons takes place and the gaining of electrons takes place. Like this, when or during the chemical reaction, the number of electrons lost, gained or shared. So that number of electron, that number is called as a valency of that elements. And what is the valency or what is the number of electrons are involved in the chemical reaction, or what is the valency of first group elements and what is the valency of second group elements? So like this, group wise we have to know their valency guys. So see here, the valency of first group, second group, 13th group and 14th group, we have the definition, this one. So that definition is, the valency is equals to number of valence electron. Just remember guys, this definition only applicable for group 1, group 2, group 13 and group 14. So see here, already now in a group 1 we are having 1 electron in their outermost shell. So the valency of group 1 element are also 1, because I already told you the example of sodium loss of 1 electron. Sodium loss 1 electron in a chemical reaction. So the valency of this sodium, this element is 1. So the group 1 elements are having the valency 1. And next, in a group 2 element, in a second group element, we are having 2 electrons in their outermost shell. So the number of electron or the valency of second group elements are 2. And in a group 13, the number of electrons present in outermost shell is 3. So the valency is also 3. And like this, in a group 14 also we are having a 4 electrons in their outermost shell. So we are having a 4 valency to the group 14 elements. Here I am not talking about the D block elements, means the transaction elements, and F block elements. F block elements means lanthanide series and actinide series. This shows a variable oxidation state or a variable valency. So these are little bit complicated. You learn in your 12th class guys. Here I am talking about only S block elements and P block elements. In your NCERT syllabus also they give to the 11th class S block elements and P block elements. Just come to the point guys. In a group 14 we are having a 4 outermost electron. So the number of valency electrons are 4 in a group 14 element. Why? Because the definition only applicable to these groups. Just remember guys, that is the valency is equals to number of electrons present in their valence shell. And next, what about group 15, 16, 17 and 18? Here the definition of valency is Here the definition of valency is 8 minus number of valence electron. 8 minus number of valence electron. Just see here guys, the valency of a 15th group is, just apply the definition, 8 minus number of valence electron means 5 is equals to 3. So the valency of 15th group is 3. The valency electron, the number of valency electron for 15th group is 3. So like this, 8 minus 6 is equals to 2. 8 minus 7, 1. And 8 minus 8, 0. So 3, 2, 1, 0. So these are the valency of group 15, 16, 17 and 18. See the definition for 15, 16, 17 and 18th group guys. That is, the valency is equals to 8 minus number of valence shell. So here what happened, I wish to write a plus 1 and a plus 2. Here I wish to write minus. Why I write a minus and why I write a plus? Just think of that. Already you know that in a chemistry, when the element lost an electron, we mentioned with a positive sign like this, plus 1. And if the element gain one electron, then we mentioned minus 1. Already you know that. So here the elements are lost the 1 electrons. Here the elements are lost the 2 electron. Why these elements are lost the electron and why these elements are gain the electron? See here guys. Sodium and chlorine. Sodium having atomic number 11 and chlorine having atomic number 17. I already told you the all elements are wish to attain their stable state or their noble configuration, or they wish to attain their octet rule. So what is the meaning of an octet rule? And I detailedly explain about this rule in next classes. Just remember, they wish to attain octet rule means in their outermost shell they wish to have 8 electrons, or all elements are wish to attain their stable state or their noble configuration. For example, already you know that neon having atomic number 10 and argon having the atomic number 18. Here sodium wish to attain the stable state means this metal attain this configuration. Here this sodium wish to have 10 electrons because to become stable, because it try to attain their noble configuration. So like this, then observe in the case of chlorine, 18 is also a stable configuration, 10 is also a stable configuration. If chlorine wish to attain the stable configuration, losing the 7 electron is easy or gaining the 1 electron is easy. So which one is easy to chlorine to attain the stable configuration? Losing 7 electron is too difficult. So what happened? Chlorine gains a 1 electron instead of losing a 7 electron. Then what happened guys? By gaining a 1 electron, the chlorine easily attain their stable configuration. So these are having a capacity to gain the electrons to easily attain their stable configuration. And already you know that these group elements are having a more electronegative capacity. So they are having a capacity to attract the electron. Why? Because they wish to attain their stable configuration easily by gaining the electron. So here I wish to mention their valency in a negative sign like this. So this is all about valency of the elements. And next we know about the trend in a valency. Just observe here group 1, group 2 and group 13 and group 14. Here the first, what happened, the valencies increases 1, 2, 3, 4. And next observe here group 15, 16, 17, 18. Here the valencies decreases 3, 2, 1, 0. So the trend in a valency in a period wise, what happened at the starting, the valencies are increases here, and next in a group 15, 16, 17, 18 at the last, here the group here the valency is decreases. So this is the trend of valency of the electron. And next I wish to summarize this video in these 5 points. Just if remember these 5 points. The periodicity of valence or oxidation state. The valence of representative elements means the S block elements and P block elements are together called as representative elements, is usually equal to the number of electrons in a outermost orbitals or valence orbitals, or for these group equal to 8 minus number of outermost electron. And the next point is oxidation state is frequently used for a valence. Oxidation state is also used for a valence. And next, the transaction elements and the actinides exhibits a variable valencies. I already told you, here I am not talking about the transaction and the actinides because these elements shows a variable oxidation states or a variable valency. So this is little bit complicated. And next, the valency of elements increases from 1 to 4. Here I already told you the trend is increased first 1 to 4 and then decreases 4 to 0. And just observe, when we move down the group, here I am talking with a period. When we move down the group, the number of valence electron remains the same. Already you know that in a group 1, all elements are having a 1 electron in their outermost shell. So they are having a same valence electron, then their valency also same in a group wise. So when we move down the group, the number of valence electron remains the same. Therefore, all the elements in a group exhibit the same valency. Just remember these 5 points, then easily you know about the valency and the trend in a valency, guys. And next one is the anomalous behavior of an elements. Here first we have to know the meaning of anomalous. So what is the meaning of anomalous? Anomalous means something different or special or unique. Means which elements shows anomalous properties, means which element shows different properties in a periodic table. Just see here, observe the second period elements. Already you have heard the particular groups having the similar properties elements, or the elements present in a particular groups are exhibit a similar properties. Means in a first group, lithium, sodium, potassium, rubidium and cesium shows a similar properties, and like this. And next come to the second group, magnesium, calcium, strontium, barium. So these are all elements are also exhibit a similar properties. Means the particular groups are having similar properties elements. Already you know that. But here what I am going to tell you, just observe Our second period elements are shows anomalous properties. Second period element shows anomalous properties, means these second period elements like lithium, barium and boron, carbon, nitrogen, oxygen and fluorine. So they shows something different properties, or they shows anomalous properties than the rest of the elements present in their particular groups. Means the lithium shows something different properties or something anomalous properties than the sodium, potassium, rubidium and cesium. And next, beryllium shows a different properties than the magnesium, calcium, strontium and barium. So this is called as an anomalous properties of a second period elements. I hope you got the meaning of anomalous, means different. The second period element shows a different properties than the rest of the elements present in their particular groups. So why they shows the different properties? So why they exhibit different properties? Because of the reasons are, just I wish to write here. The second period elements are having a very small size, very small atomic size than the rest of the elements. Means lithium have a very small atomic size compared to the sodium, potassium, rubidium and cesium. And next, beryllium is a very small atomic size compared than the magnesium, calcium and strontium, barium. Means the atomic size or the atomic radius is having a large difference between the second period elements and the rest of the elements in that groups. So this is also one reason they shows the anomalous properties. And the next reason why they shows the anomalous properties is they are having a high ionization enthalpy. High ionization enthalpy. So what is the meaning of high ionization enthalpy? Already you know that the ionization enthalpy means the energy required to remove an outermost electron from an atom. High means here we required a more energy to remove an electron from that atom. So here we want a high ionization energy in a second period elements comparing to the rest of the elements present in that group. And then these second period elements are having high electronegativity. High electronegativity means they are having a high capacity to attract the electron comparing to these elements. And the next reason is they are having a high nuclear charge. They are having a high or a large charge. So these properties are makes the second period elements shows a different properties or anomalous properties than the rest of the elements present in their group. So what was the reason? Once I wish to repeat, they are very small in size and they are high ionization enthalpy. They are having a high ionization enthalpy and they are having a high electronegative property and they are having a high nuclear charge or the large charge. So these reasons are makes the second period elements are shows a different properties or anomalous property than the other elements. Just see here, I wish to take one example. Consider the first group. We are having a lithium, sodium, potassium, rubidium and cesium. I already told you the lithium shows the something different properties, and the lithium exhibit anomalous properties than the sodium, potassium, rubidium and cesium. So how it is different from these elements? Just I wish to take an example here. Already you know that the first group elements and the second group elements are very soft metals. You now by the help of knife we can cut the metal sodium, potassium and rubidium, cesium. But lithium is little bit hard than these elements. So the first group elements are soft metals, sodium, potassium, rubidium and cesium, but lithium is little bit hard. Lithium is hard than these elements. And next, the sodium, potassium, rubidium and cesium are quickly reacts with the air and water. They are quickly reacts with the air and water. But lithium not quickly reacts with the air and water. They are quickly reacts with the air and water, but lithium not quickly react with the air and water because it has a high ionization enthalpy, high electronegativity, and the lithium have a very small atomic size comparing these elements. So these are the reason this lithium not quickly react with the air and water. And next, see here, already you know that the first group elements like sodium, potassium, rubidium and cesium are very strong base like NaOH, KOH, like this. They are considered a strong base, but LiOH, lithium hydroxide, not a very basic, not a strong base. They are very basic or strong basic, but the lithium is not a very basic. So like this, here also lithium is something special than these elements. And next, all elements means sodium and potassium, rubidium and cesium makes ionic compounds. So like this, these elements means sodium, potassium, rubidium, cesium, magnesium, calcium, strontium and barium. So like this, these elements are form ionic compounds, cation, anion. So like this, these are form ionic compounds, but the lithium compounds are covalent. So the lithium forms a covalent compound. So this is also anomalous properties of lithium than these elements. Just remember guys, lithium, beryllium and boron, carbon, nitrogen, oxygen and fluorine, the second period elements are leaders of their groups. Just remember this point. Why they are leaders? Because they are having the special properties like very small atomic size, high ionization enthalpy, high electronegativity and high nuclear charge or the large charge. So that's why they shows a different or anomalous properties than the many other elements belong their particular groups. So this is all about the anomalous properties of a second period elements. I hope you got the point about this anomalous properties of this second period elements. And the next anomalous property is diagonal relationship. Just observe here guys, these are the second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. And these are the third period elements: sodium, magnesium, aluminium, silicon and phosphorus and so on. So like this, you know the elements present in the same group exhibit similar properties. Means these are all also exhibit same properties, and these are all elements exhibit same property which are present in a second group only. If I write the 13th group elements, boron, aluminium, gallium, indium, thallium. So like this, so these elements which are present in this similar group, so these elements are also exhibit a similar property. But why they shows a similar property? Because they are having a similar electrons in their outermost shell. So the elements present in a similar group shows the similar properties. But come through the period, lithium is having a different property, beryllium having a different property, boron having a different property. Means a period wise they are not having a similar property, just group wise they are having a similar property. This concept already you know that and you know very well. But here what happened, the first group element lithium shows a similar property with a second group element. So this is the anomalous property of these elements, lithium and magnesium. The magnesium exists diagonally with a lithium. So this is called as a diagonal relationship. Like this, the beryllium shows a similar property with the aluminium. This aluminium also belongs to another group. Beryllium also belongs to another group. So they are present in a different groups, but they are shows a similar properties. Beryllium have a diagonal relationship with the aluminium. So like this, the boron also exhibit a diagonal relationship with the silicon. Means silicon exists diagonally with the boron, and boron and silicon are shows a similar properties. So this is called as a diagonal relationship. So why they shows a similar properties? Because they are matched in their atomic size. Means the lithium and magnesium are having almost all same atomic size, and the beryllium and aluminium are also having a same almost all similar atomic radius or ionic radius. So they are having a same atomic size. And next, like this, boron and silicon are also having a same almost all similar atomic size, though they are having or they shows a similar property. Even they are present in a different group also. So this is called as a diagonal relationship. So this is also another anomalous properties of an elements in a periodic table. So these two properties means the second period elements are also shows the anomalous properties than the rest of the elements in their particular group, and the second period elements like a lithium, beryllium, boron are also shows the diagonal relationship with the magnesium, aluminium and silicon. Diagonal relationship means lithium, magnesium, beryllium and aluminium, boron and silicon, which are placed diagonally, they placed similar properties even they are in a different groups. So this is called as a diagonal relationship. The diagonal relationship is not exhibit all diagonally placed elements. The carbon and phosphorus are not exhibit the diagonal relationship. The carbon shows the different properties and the phosphorus shows the different property. Just remember, in these pairs, lithium, magnesium, beryllium, aluminium, boron and silicon. So in these pair only we have to observe diagonal relationship. Just I wish to summarize this video through these points. Just observe and remember these the anomalous or a different properties of elements. So the first element of each group, like this is the first element of each group, lithium, beryllium and boron, carbon, nitrogen, oxygen and fluorine. So see here, the first element of each group, lithium, beryllium and the group 13 to 17 means this is belongs to 13th group and this belongs to a 17th group. Boron to fluorine differs in a many respects from other members of their respective groups, means they shows a different properties, they shows a different properties from the other member of their respective groups. And the next one is the behavior of lithium, beryllium is more similar with the second element following group, means this is the second element following group, magnesium and aluminium. The second element following group, that is the magnesium and aluminium respectively. So this sort of a similarity is commonly referred as a diagonal relationship. So these elements similarity is called as a diagonal relationship. In a periodic properties, the anomalous behavior is attributed to their small size, large charge, and they are having a high electronegativity and they are having a high ionization enthalpy. So by attributing these properties, they shows different properties or anomalous properties. So this class completes here guys, and in next class I will come with the periodic trends and a chemical reactivity. Bye bye.